This is a video of the Mod 102 kit. You can see the kit on the table, and here we have the on and off switch, the indicator light, the volume control, bass control, treble control, input jack, power transformer, speaker output transformer. And this is the metal shield. The tube is not inside. I have one tube. This is the second of the other tube. This is not powered on right now, it's all powered off. I'm going to show you some of the tools you need to construct the kit. You need a drill to chuck the drill, and you're going to use the drill to twist the wires together. The reason you want to twist the wires together is because the filament circuit is AC voltage, not DC, and it can pick up 60 Hertz hum. And by twisting the wires together, the magnetic field of one wire cancels the magnetic field of the other wire. Because anytime you are passing electricity to a conductor, it has a magnetic field. But if you have a conductor wound opposite that conductor, it's in opposite phase and the magnetic fields cancel each other. So you use the drill to twist wires together, by which you cancel out the hum pickup, which would normally be in the filament circuit. Over here you'll see some fine tip screwdrivers, and the other reason you need the drill is because of this tip, which is a stone tip. You put this in the drill, and the reason I like this tip was because this is an absolutely necessary step that is not, it is mentioned in the instructions, but it's not emphasized. This tip, once the stone is on it, is used to clean out all the holes that these controls go into. And in the back of the little amplifier, we have the fuse and the output jack, which will go to a speaker. And these holes likewise have to be cleaned out, on top of which you have metal screws which attach the transformers to the chassis, as well as screws which hold down the various connectors to the chassis. And that's where this comes in, which are two files which will help you file down the paint. What happens is the paint is an insulator, and the whole thing is insulated, including the holes. For a good ground, these holes must be stripped of the paint, and that's where this drill bit tip will remove the paint from the holes, and these files will remove the paint from the smaller holes which are inside. Because without a good ground, there's no continuity anywhere in the circuit. So first, let's talk over the external components of the amplifier. Let's talk over the internal components. Power transformer has multiple outputs: 120 volt input current, 360 volts output current, which is converted to DC. Notice there's no rectifier tube, only an audio dual triode tube called a 12AX7, which is two triodes in the same glass envelope, and pento tube, which acts as the power stage. So this saves the complexity of a diode by using solid state diodes, which I'll show you in a minute. And so this is the power supply side of the house. This is the impedance matching side of the house, where the anode circuit is high impedance, about 3000 ohms, but the output is low impedance, about 8 to 16 ohms. So the transformer acts as an impedance matching circuit, essentially. And so that's what this transformer is used for. Now, in transistor circuits, you don't find that very often, but in tube circuits, you do. This circuit is somewhere around, I guess, 1956 in design, but the amplifier is brand new. But the circuit has been around from late 1950s to the 1960s. Let's talk about all the other parts you need. So you need a wire stripper. I mentioned the two files, a heavy wire cutter, a light cutter for finer cuts, Phillips screwdriver, and soldering iron, and helpful is a soldering sucking iron to suck out the solder in case you made a mistake in making a connection. Now what I have here is a multimeter, volts, ohms, and so forth. But what I also have here is a continuity tester, which my ohm meter does not have a continuity test feature. And this is a cheap $8 continuity tester, which works much faster. Before we talk about the rest of the circuit, let's talk about the idea of how the circuit works. So the basic operation theory, and I'll show you the schematic in a later video, is an input circuit comes in, it provides a high input impedance to the audio device feeding the signal, whether that's a microphone, a guitar, a CD player, a record player, whatever. You want to give it a high input impedance, not to pull down that stage, which is only millivolts. The first triode then converts millivolts to volts and is acting as a voltage amplifier, not a power amplifier. The second stage of that same glass envelope is this another triode, which acts as an equalizer circuit, where you have your tone controls. It also acts as an impedance matching circuit between the first triode, which is just a voltage amplifier, and the power amplifier, which is the pentode. And because it's not a push-pull circuit in the pentode circuit, in the push-pull circuit the sine wave goes up and then goes down, and you're amplifying half the sine wave and then the other half of the sine wave, meaning you have 50% efficiency. In this circuit we're dealing with 100% on all the time, so it's a class A amplifier and a class AB amplifier. And this circuit is pretty much complete, but I'm not going to go over the entire circuit, but only the power supply aspect of this circuit. So let's talk about the power supply. If you notice, we have rubber grommets here and here, as well as here and here. And the reason for the grommets is it prevents the wire from chafing. So these two grommets are the little transformer you saw on top. One side is input, one side is output. This is the output, which is 8 ohms, goes to the output jack. This is the input, which is 3,000 ohms approximately, and it goes and gets from the amplifier section. So think of it, this is the amplifier section, and think of this as the power supply section. This is the power supply section. This is the audio section. Think of the right half of the circuit as audio section, left side is power supply section. That's how roughly you can look at it. Over here, the AC current comes in through the AC power cord. The green wire of the AC power cord then goes right here, which is the ground. This is the other ground, and every screw here is a ground actually. So it goes on the hot side through this fuse, out of the fuse into the big transformer on top, and through the switch. One side of the switch goes to the power cord, the other side of the switch goes to the other part of the transformer. So the white wire of the big transformer is this one, and the black wire is this one. So these black and white wires respectively supply the transformer after passing through a fuse and a power on switch on each leg. So then the high voltage winding, the red is red 1, red 2 is the 360 volt wires. Here you have a yellow and a red. It goes to ground. It's the center tap of that transformer, returning the full wave rectifier using two diodes back to ground, which is how you're able to get full wave rectification using two diodes rather than a bridge circuit. So basically think of these three red wires, red, yellow, as the 360 volt side. Think of the green wires, which is this, is the low voltage filament side. So the transformer has a low voltage output, the green wires, which are twisted, and a high voltage side, which is the red wires. Think of this as the high voltage circuit, with capacitors to filter the pulsating DC to smooth it. And think of these as low voltage wires, which act as the filament circuit. So the low power section of the AC side goes through this lamp which indicates power on, and then going through this twisted wire. I already explained why we twisted it. Goes to the filament on this tube, and then the filament of this tube drives the filament of this tube. So this tube's filament is in parallel with this tube's filament, and they're both in parallel with this light bulb, and then this light bulb is supplied power by the green twisted pair from the transformer. So the low voltage 12 volt circuit is this circuit right here, driving the filament and the light bulb, and the high voltage circuit is here. And let's look at the greater detail in that circuit, which I'll do in a follow-up video. It's hard to look at a wired product and understand the schematic. This is the cathode bias circuit, where we have a high capacitor and a big wattage resistor acting as the bias circuit of the cube. For those which don't know what that means, you have to create a reference voltage to the alternating current coming in, and this machine is self-biased. So the input jack has this input, has a big 1 mega ohm resistor which acts as a 1 mega ohm input impedance. We have a 1 mega ohm volume control, 250K treble, 250K bass. These capacitors and this resistor form the equalization circuit or the tone control circuit, and it gets fed off of this section, which I'll explain in a follow-up video. This amplifier is not a complicated circuit. It's two tubes, triode, followed by a pentode, with one glass envelope containing two triodes. Overall, this amplifier is straightforward to build. It's very time consuming to build. It takes about 12 hours to build. You have to have good soldering skills not to create a cold solder joint. And this amplifier requires a great deal of attention to detail. You have to follow both the drawings as well as the schematic. The maker of the kit provides the schematic as well as the drawings step by step, so you don't build it all at once. You're doing first the wiring without any of the capacitors or resistors. First you're running all the wires just as connections regarding just wires. Then you do the power supply circuit, and you do that. Then you do the AC circuit. It comes with a troubleshooting section to figure out voltages at each respective circuit. Rather than show you this amp from an audio quality point of view, which maybe a musician cares about, I'm more concerned explaining the construction of it and the testing of it, and that's how this video will be shot. So, see you in a follow-up video, and I recommend this kit. This is not a bad kit for a science fair project. It's all point-to-point hand wiring, no circuit board. It's how things used to be built in the 50s and 60s, before I was born even. But you certainly can't go wrong in learning how to construct the old way. There could be a lot more parts on this chassis, but they would be more crammed together, and for a non-experienced builder, that actually is not to your advantage. So they actually thought it through to make it not too crammed in terms of component count, making it easier to assemble. It's also a self-bias circuit, making it easier to adjust. Not bad for a $215 kit. Yes, you can buy 50 watts of power for about that price, but this is a tube circuit, so the parts are no longer as common as they were in the past. The transformers alone are pretty expensive, and the metal chassis is well made. Again, I wish to emphasize that a very important point is to clean out the holes to have good ground. For example, if we hook up this metal clip here, Let's pick any spot. Let's pick the spot right here. Let's pick potentiometer. As you can see, we have continuity. If I touch this potentiometer, we have continuity. If I touch this potentiometer, we have continuity. If I touch this metal screw, we have continuity. If I touch this, we have continuity. If I touch this, we have continuity. If I touch anything metal which is not painted, we have continuity, which is very important in this circuit. So unless you clean those holes, you're not going to have continuity. Another thing you can use the continuity tester for is to trace your wire connection. Again, the continuity tester must only be used with no power applied to the circuit. Very important. Also, this is a high voltage circuit, 360 volts. So it's high voltage, low current, but in a high voltage circuit, if you don't know what you're doing, you're going to get electrocuted and you're going to get burnt. So remember, even if the amplifier is turned off, these big capacitors hold charge. Now, there's a bleed resistor on each capacitor, which are here. And there's a third one which has to be still soldered. This is not full line. There'll be 3 capacitors total, forming C1R1, C2R2, C3R3. In other words, at each voltage point, it becomes more and more filtered as you go down the chain, and each resistor drops the voltage a little bit, like a voltage divider network. But remember, the capacitor holds charge, so even if it's turned off, don't put your hands inside for at least 10 minutes until these discharge. Also, the thing to know about a tube amplifier is never power it on without a load, either a dummy load or a speaker, which I'm not showing you here. But this output jack, which is right here, must always have a speaker attached or a dummy load. If you don't have one attached, don't turn it on. So again, the safety precautions are always have an output load, number 1. Number 2, wait for the tubes to warm up. It's not instantly on like in a transistor circuit. The tube takes 8-10 seconds to warm up before you have anything. That's number 2. It's a high voltage circuit, number 3, so know what you're doing. You are dealing with a 120 volt circuit, not stepped up to 12 volts, but stepped up to 360 volts. In a transistor circuit, 120 volts is stepped down to about 13.8 or 14 volts. In this circuit, 120 volts is stepped up to about 360 volts. And so, in the later video, I'll show you troubleshooting, but I wanted to give you all those caveats, show you the tools, and we'll talk about the schematic and how it operates, and how it's biased a little later, and how to test it a little later. Yes, you can test it by hooking up a speaker and a microphone. That's not what we're going to do. Before we ever plug it in or do anything, we're going to show you how to test continuity along specific points, then how to test voltage with no tubes plugged in the power supply section. Test that out. Then we're going to show you how to test voltage at certain pins on the tubes without the tubes being in there. And only then we're going to power it up and show you how it works as an audio device. And that's that. So this video is focused on the construction and the testing of an audio amplifier, more for an engineering audience, not for a musician audience, although a musician audience which wants to work with audio tube amplifiers, which sound warmer and richer than transistor amplifiers, I think, certainly can benefit in looking at this video. Okay, part 2 coming up next.